I want to expand on the substitution method just a little bit, as well as talk about some different situations that pop up. So for this problem, the issue with this is we don't have a nice pretty formula that's ready to plug straight in, okay? So when you look, you don't have x equals or y equals in either of these examples. So the first thing you have to do is identify, well, which one is going to be easier to get to that version that we want, okay? So I hope that you kind of look at this and notice that that x is kind of hanging out almost by itself. At least it doesn't have a coefficient on it. So it might be a little bit easier to isolate, okay? So here's how I'm going to handle this. I'm going to take this equation kind of up out over here on the side, and I'm going to say, okay, x minus 3y equals negative 2. And I want it to say x equals. So if I need to cancel out negative 3y, the inverse of minus 3y is plus 3y to both sides. Okay, this way negative 3y plus 3y cancels out. And I'm left with x equals negative 2 plus 3y. You can go ahead and you can't combine them together. So negative 2 plus 3y. Now I have that pretty formula that we wanted, okay? We've got the actual x equals formula. So there's my formula that I'm going to use. And I'm going to be plugging it back in for x. Now you have two x options. When you rearrange one of these, I would always recommend you kind of cross it out so that you're not tempted to go back into where you started, okay? If you plug it back into where it came from, you're going to have some issues. It's going to pop up some odd scenarios. So make sure you plug it into the other equation that you have not used yet, okay? So now I'm going to rewrite this top equation, but instead of having an x, I'm going to put my formula, negative 2 plus 3y. Then I've got to finish out the rest of the equation. So plus 2y equals 16. Same as every other problem I've got from this point. So I distribute and get negative 6 plus 9y plus 2y equals 16. Go ahead and combine like terms and you get 11y. So negative 6 plus 11y equals 16. This is basic solving equations. If I'm trying to isolate y, I'm going to add 6 to both sides so that that cancels out. And I end up with 11y equals, that would be 22. When we divide by 11, you end up with y equals 2. Okay, now that I know half of the answer, I know that y has to be 2. I can use that information back up here. And here's the thing, I can actually plug this into any y. If I know that y is 2, I could say, well, I'm going to call that y2, or I'm going to call that y2. It really doesn't matter. I personally think this one is a little bit easier. So I'm going to plug back into that equation and say, okay, x equals negative 2 plus 3 times 2. And so I end up with x equals negative 2 plus 6, and negative 2 plus 6 would end up working out to be positive 4. When you write your solution on this, when you write your answer, go ahead and get in the habit of putting them in alphabetical order. Just like an ordered pair, x comes first, y comes second. Okay, so we end up with 4 and 2. So you might make a little note to yourself to solve for a formula when needed. Hopefully you won't have to do this very often, but if you don't have a formula that's ready to plug in, you may have to kind of manipulate one of those equations a little bit so that then you can actually plug it in, okay? All right, now another kind of little added tricky part to this is something that pops up on these examples. So let's see. The good news is it is totally ready to substitute. So I'm going to take my equation here, negative 2y plus 6, and I'm going to plug it in for x. So this will turn into, let's see, 3 times negative 2y plus 6 plus 6y equals 8. So it's the second equation just with x replaced. I'm going to distribute and get negative 6y plus 18 plus 6y equals 8. Okay, now I'm going to combine like terms. So when I go to combine negative 6y plus 6y, I actually get 0y plus 18 equals 8. Now, when I start looking at this, 0y, well, 0 times anything is really 0, okay? That's gone. So I'm going to go ahead and just ignore it. I don't even have to really write it down. You're not going to solve and isolate y when it has a 0 with it. It's gone. It's non-existent anymore. So I end up with this weird situation where it says 18 equals 8. Well, last time I checked, 18 does not equal 8, okay? So we saw this when we were doing single equations. Not very often, but it did pop up. When you get all your variables to disappear and you end up with something that does not match, that means that this problem actually has no solution, okay? That means there is absolutely no x value and y value combination that will fit both of these two equations. If you get one to fit this, that makes this actually equal 8, it will not work in this equation. If you come up with one that works in the top equation, it will not work in the bottom equation, okay? So in this situation, there is no solution, no combination that will ever work. The second problem looks almost identical to it. X equals negative 2y plus 6, 3x plus 6y equals 18. So I have a formula that's ready to go. I'm going to take that and plug it into the x, just like I did on the last example. So this would now become 3 times negative 2y plus 6 plus 6y equals 18. And it's very, very similar to the problem we just did. I distribute and get negative 6y plus 18 plus 6y equals 18. Again, we have this situation where negative 6y plus 6y becomes 0y plus 18 equals 18. Well, 0y cancels out, and I end up with 18 equals 18. In a normal equation, in a single equation, we called this all real numbers, okay? If you did it on maybe PhotoMath, it would give you that cool, fancy looking R value. Well, it gets a slightly different label when it is coming from a system of equations. Instead of saying all real numbers, it's not that x and y can be anything in the entire planet. It's really that there are an infinite solutions to this problem, okay? It means that there are an uncountable number of combinations that will make these two formulas work, okay? If you get one that makes this equal 18, it will always work with the top one as well, okay? You could come up with any combination you want. If it works in one equation, it will work in the second equation as well, okay? So there are an infinite number of combinations that will work, not just one. So if all your variables cancel out, then it is considered a special situation. And it could either be a no solution or it could be an infinite solution. So if the numbers don't match, it's going to be no solution. If you work it out and the numbers do match, 18 equals 18, then it's infinite solutions there, okay? So again, it's only if all the variables cancel out, all right? Okay, hope that helps with these. They're rare, they don't pop up very often, but you do see them from time to time.